Hi guys, this is Amin, and we'll be doing the hydration of norbornylene investigative experiment today. So let's get started. Hydration. Hydration is the process of combining a water molecule to a substrate and having a hydroxyl group and a hydrogen group attached to it. As we can see here, we have an example. You've got an alkene here with a hydronium ion, and you result with a hydroxyl group on it. It's really good in breaking down a molecules, which we'll see right away. So utility, like I said, hydration is used in the breaking down of molecules, and we see that most in digestion, right, when we're eating something. And it really allows for greater absorption of that material because it increases the surface area. I also found that the production of paper and biofuels was really great. From cellulose was a great example for hydration. Nucleophilic substitution reactions. These reactions specifically utilize an electron-rich nucleophile attacking a positively charged electrophile. As we can see here, the leaving group leaves, making the central carbon there a positively charged carbon, acts as a positively charged electrophile, and the electron-rich nucleophile attacking it. And you result in two different products there, hence the different positions. Replace the leaving group and whatnot. Acid catalyzed hydration. Acid catalyzed hydration is a nucleophilic substitution reaction, which is what we just spoke about. However, in the presence of an acidic compound, such as the protic acid in this case. And it also adds the water and it used in breaking down of chemical bonds. In this case, the hydronium acts as a catalyst, and alcohols are added to alkenes there. I've got a mechanism here trying to explain the acid catalyzed hydration there. Just quickly drew up. We've got the water acting as a nucleophile, trying to attach there. You also see that another water molecule is used to neutralize that water molecule into a hydroxyl group. And we are left with a hydronium ion as an additional byproduct. So norbornylene. Norbornylene is the substrate that we're using. And as we can see here, it's a cyclic hydrocarbon, so it's got a cyclohexane ring, right? And it's got a methylene bridge in the middle with a double bond on the side there. The whole structure is really critical to our whole experiment, so it's important to know that. It also has a melting point of 42 to 46 Celsius, which is again crucial because we'll be using melting point in the future right away. And it also is a white solid and has a sour odor, and the white solid would be crucial as well to our experiments. It's used in anti-vibrational materials such as rubber and shoe materials, as well as the rail industry, which is important. So our experiment specifically is an investigative experiment. You'll see that stereoselectivity plays a huge role in it. So you take norbornylene and you perform hydration to it, and you produce two products at the end. I'll quickly show you the two products right away. And you'll see that only one of the products in this case will be formed due to stereoselectivity. The techniques we are using are sublimation. The hypotheses that I've come up with is that the exo position would be most favored due to the stereoselectivity. So let's see what happens. Here are the two products would be formed. So you have norbornylene right there, and you've got the water molecule there present, and it would produce either the exo position or the endo position. The key thing to note in this slide specifically is that the melting points, they vary for quite a bit, right? You have at least a 25 Celsius difference. You've got for the exo position 124 to 125 Celsius, and for the endo position 149 to 150 Celsius, so a huge difference. Steric hindrance, as I mentioned, stereoselectivity is crucial in this case. So steric hindrance is an important concept to discuss. It's the accessibility of other molecules attaching due to the electron groups formed by the existing molecules around it. And as we can see here, you've got an example of the two molecules there. You've got two bulky groups for group A, for carbon A, and you've got for carbon B, you've only got two hydrogen molecules. And as predicted, the nucleophile will attach carbon B that just has the hydrogen molecules because the methyl groups are so bulky, and it will be too sterically hindered. The mechanism for the acid catalyzed hydration of norbornylene itself. So we talked about acid catalyzed hydration, talked about norbornylene. Now we're going to put them together and see how what products are produced and how, basically. So we see that there's the hydronium ion there, the nucleophile, the alkene, the double bond is attacking the hydronium ion. It is then moved on to the norbornylene there with the water molecule, because now it has a positively charged ion on it. Another water molecule is again then used to neutralize the water molecule, taking away one of the hydrogens, leading to a hydroxyl group left in the endo position. And the same procedure follows for the exo position, which we can see here. And I've just written the melting points once again for you there. For the experimental part, I discussed this in further past slides as well, where sublimation was a huge, it's a technique used in this experiment specifically, and basically it's the phase change from a solid molecule to a gaseous molecule. And I've just got an image there to show you what it would somewhat look like, and it was used for the purification of norbornylene. Sublimation in lab looks like this here. So we used a cold finger to do it. It was a homemade cold finger that was provided by Dr. Latmeyer, and as we can see, we're using it there. A roto-evaporator was also one of the techniques that were used, or one of the instruments that were used to perform the technique, and it was basically to remove the solvents from the sample through evaporation. And we've got this cool looking machine right there, and it was very interesting to learn more about it. So some of the data collected from that whole product was simply the melting temperature of the product, which was determined. And as we can see here, the product on the 28th day had a melting temperature of 109 to 110 Celsius. It varied when I took the melting point. So that was that in the 28th day. And we do that because we try to dry the product itself. So you have to wait for that product to dry itself. So I just let it sit in my locker. The color was also off, as shown there in that table, because norbornylene is supposed to have a white looking product, right? It's supposed to be a white solid. However, my product was a peach beige, and we'll talk about why that was that. So, and the melting point, as we can see, that it matches the exo position as proposed in my hypothesis. Thus, my hypothesis is correct in that sense. So the reasoning for the color itself, the off peach beigey color, is that when I was performing the reaction itself, the filter paper, right before performing this, the sublimation portion, the filter paper might have ripped or had a small hole in it from possibly excess poking, or just was a thin paper or whatnot. And we can suspect that the magnesium sulfate, which was the drying agent used, could have been present in the product due to its peach beigey coloration. And as we can see there, that was that. Some of the other collected and calculated data we had to perform in this example was the theoretical yields, the product weights, the actual yields, and the percent yields. So as we can see, the theoretical yield is quite high. It's 4.713 grams, whereas the actual yield of my product was 0.309 grams. Now that's a huge difference. difference. And the reasoning behind the actual yield being so low, hence the percent yield being so low, was that the sublimation portion itself. The process of sublimation is supposed to lower your yield. It's supposed to get rid of most of that product when it's performing that process. So this was expected after all. And as we can see, our percent yield then turned out to be only 6.56%. So we could just assume how much that sublimation process had to take it up right there. Sources of errors that might have occurred in the experiment itself would be some systemic errors, instrumental errors, random errors. One error that we can talk about that we just discussed was the ripping of filtration paper due to poking or something. And some systemic and instrumental errors include like miscalibration, or I might have read the instructions wrong, something like the using of wrong instruments, the using of wrong techniques when performing the instruments, and so on, and just random error as well, right? All experiments involve random error, that even though the experiments occurred, for some apparent reason, the pressure in the room or the environmental aspect of the room might have altered the experiment itself. For future alterations, I would like to suggest some alterations to the sublimation portion of the reaction, and that would be like a closed cold finger, or the addition of partial vacuums. And after discussing with the instructor, I found that the closed cold finger actually has a lower yield than needed, and it could be a worsen off alteration, but that has to be determined. With the experiment itself. However, it does have a higher purity rate, which is interesting. And the addition of partial vacuum also alters the reaction in a certain way, where you've got a lower yield as well. So similar alterations in the future that could have been performed to the experiment itself. So in summary, as we talked about, we did a hydration reaction on norbornylene, which was a stereoselective addition reaction. We used acid catalyzed hydration to it because in the presence of protic acid, we did that. And that we basically determined the final analyzation was performed by collecting data such as the color and the melting point. We found that after letting the product dry completely, on the 20th day, the melting point was found to be 109 to 110 Celsius. And that overall is most closest to the exo position that we saw there. Hence our hypothesis, which was that the exo position would be most favored due to our knowledge of steric hindrance, was true. So the experiment overall was a success. However, due to some random error, the coloration was off. We got a peachy beige coloration instead of a white one, due to the possible presence of magnesium sulfate, maybe, which is why that coloration was off. But overall, that was the hydration of norbornylene. So here are my references. I hope you guys enjoyed my presentation and learned something from it. Thank you very much.